Find the value of dy by dx at the point where x equals 2 on the curve with the equation y equals x squared times root 5x minus 1. So first thing to note here is we're differentiating and we're going to have to use the product rule. Because we have the product of two functions, we've got the x squared multiplied by the root 5x minus 1. So for the product rule, let me write this down. U can be my x squared, v can be the root 5x minus 1, which I'm writing as 5x minus 1 to the power of 1/2. Differentiating then. Differentiating the x squared gives 2x. Now to differentiate the v, I'm going to have to use the chain rule for this. Because first I'm going to need to differentiate the power. And then afterwards I'm going to have to differentiate the inside, so multiply by 5. So just dealing with the power first, we'll have 1/2 times 5x minus 1. Take 1 away from the power. So 1/2, take away 1 is minus 1/2. And then, like I said, using the chain rule, I need to multiply by the derivative of the inside function, which is 5. Which would then simplify the 1/2 times the 5 is 5 over 2. So I can actually just simplify this to be 5 over 2 at the front there. Okay, right. Using the product rule then, I can write dy by dx. I know this is going to be equal to u times v dashed plus u dashed times v. So x squared times 5 over 2, 5x minus 1 to the power of minus 1/2, plus 2x times 5x minus 1 to the power of 1/2. This is my gradient function. And remember, the question wanted the value of dy by dx when x is 2. So I'm just going to be substituting 2 into my expression now. So I'll get 2 squared times 5 over 2 times 5 times 2 minus 1 to the power of minus 1/2 plus 2 times 2 times 5 times 2 minus 1 to the power of 1/2. And as long as you're very careful with this, you will get the answer 46 over 3. That's part A. Part B. Differentiate sine 2x over x squared. So notice that this is a fraction, it's a quotient. We've got the sine 2x divided by the x squared. So we're going to have to use the quotient rule to differentiate this. So I'm going to get u to be sine 2x, and I'll get v to be x squared. U dash, then sine differentiates to be cos, and then I need to, by the chain rule, multiply by the derivative of the inside, which is 2. Differentiating the x squared, I get 2x. Right, now to apply the quotient rule, I'm actually going to write this down because it's a bit trickier than the product rule. You do get given this formula, remember. Not quite in this form, but you do get given it in a slightly different form. U dash v minus v dash u over v squared. So we'll get 2 cos 2x times x squared minus 2x times sine 2x all over x squared squared, which I can do a little bit of simplification here. The first term will become 2x squared cos 2x minus 2x sine 2x all over x to the power 4 And we can see, we don't actually have to, the question doesn't tell us to, but we probably should as good mathematicians. Do a little bit of simplification here. We can cancel the x here. One of the x's there and one of the x's there to get this is our final answer.